next submission is called HTM for Adelaide Arterial Traffic Flow. And we will have Jonathan Mackenzie on Skype to take comments after the video.
So hi, I'm Jonathan Mackenzie, and this is my presentation for the Numenta HTM Challenge. My presentation is on HTM models for automated incident detection in Adelaide, Australia. So what is automated incident detection? Firstly, we need to know what congestion is, and that's basically where the capacity of the road is exceeded, and so everyone slows down. So this can be recurrent, which you might think of as something like rush hour in the morning when everyone goes to work, and rush hour in the afternoon when everyone goes home. So our goal is to detect non-recurrent congestion, and that's where something like an accident, a breakdown, spilled load, burst pipe, landslide, flooding, riots and protests cause congestion on the road. So the problem is basically that freeway automated incident detection is well researched and there's lots of solutions for it, but we want to try and do the same thing but on arterial roads, which is much more difficult due to the varied nature of the traffic and everyone's turning, going different ways. And we use loop detectors, which are a sensor underneath the road which counts traffic, and they come with their own warts. So in our solution we use HTM to detect anomalous traffic flow. This is an improvement on previous research which mostly used simulations and supervised learning techniques, which allowed people to easily set up incidents and traffic flow and can really easily monitor everything, but we have to use real world data which comes with all its own problems. So the way my system works is we import the data, which is provided by the Transport Systems Centre at Flinders University, into Mongo database. The data is then analysed using HTM, and we review it in a Python web application. So we've currently got 3.5 terabytes of data from 7 years, and that's at 5-minute intervals. But for now I'm only looking at 2-month period, which is about 130 intersections or 170,000 data points per intersection. And this is private data, so you don't have access to it, sorry. And we also use crash data to verify our anomaly prediction, and there's 142,000 incidents. But in the period we're looking at, there's only 155, and this is public data, and you can get it from data.sa.gov.au. So here's my readings data. Basically it's just a collection of objects which map the sensor to the count of the sensor. So we can see that on intersection 3041 at 8:30 AM, there was 58 vehicles on sensor 136. And here's all the crashes, which basically just say when and where a crash occurred, and what sort of features it have, like raining, four-wheel drives, etc. So the analysis script uses HTM, and there's an option to do it with one model which takes in every sensor as an input, and then we get the anomaly score from that, but that didn't work very well, so we use one model per sensor. So if it's an intersection with 24 sensors, it'll be 24 models and 24 different outputs. But still this takes a long time, so we use a supercomputer. So here you can see the script running on my machine using multi-model, which means that there's one model per sensor which runs in its own subprocess. This is for intersection 3001, and writing the results to the database is also a smoothing option available, which we haven't used, but this applies a median filter with a window size of your choosing to the readings data. And you can see down here that this uses more processors than cores, since intersection 3001 uses 20 sensors, so it won't run as fast as it could, so we run it on the supercomputer. And here you can see the supercomputer queue with all the jobs lined up, and the supercomputer has around 1200 cores, so we can easily use as many cores as there are processors for the intersection. And then you can review it using the handy web application. So here you can see the lovely city of Adelaide, and this is the central business district, which is the only area I've added the traffic for. So we can click on an intersection and click on the button to see the data for that intersection. So here we've got intersection 3083, and it's a signalised T-junction. And here's all the readings on sensor 56. And here we have the anomaly scores in blue, anomaly likelihood in red, incidents in green, and the orange dots indicate that a sensor hasn't exceeded the threshold, given here 0.99. This button toggles taking the log of the anomaly likelihood. So if we zoom into this section here, we can see that at this time there was some anomalous traffic happening, So certainly here there was a significant dip due to this incident here. And if we mouse over, we can see that it was caused by inattention and was a rear end that cost $2,000. And down here we can see on the map exactly where it occurred. So they're going north. But it did think this bit of traffic over here was anomalous, and that was on sensor 848, etc. We can click the button to change the sensor and see what the readings were at that time. So that's that view, and we also have an incidence view where we can easily cross-validate crashes with the anomaly scores. So here we have our list of incidents with the date and which intersection it occurred at, and if any of its sensors exceeded the 0.99 threshold, then they'll be shown here with the sensor. We can filter it to only show ones which have exceeded, and we'll click on this one here, 3040. And so here we can see there was an accident at that time. If we zoom in, we can see that there was a dip in traffic at that time, and that it did come up as an anomaly on the sensors 56, 72, and 80. But they were anomalous for a while around, and you can see on the map here where it occurred. So here's some results I found. So didn't find, even though there was quite clearly anomalous traffic here around an accident, that it wasn't anomalous. And this is probably due to the very noisy nature of the data, which you can see here. And thank you for watching, and thank you to Nupic for providing this challenge, and thank you for the Numenta team for helping me out with all parts of the project.
Thank you, Jonathan. So, first off, as someone who has built traffic analysis applications with Nupic before, I just want to say that the amount of software it takes to do what Jonathan did is pretty significant. So impressive just in the maturity of the software in a short period of time. Thank you, Jonathan, for your work. Judging panel?
First of all, you look very tired, don't drive.
Yeah, I just woke up.
Question, you said that you tried to put all the sensors from an intersection into the model, and I imagine that there was some encoding that you had to do, and did you have a number of choices to make, and you said it didn't work very well. Can you say more about that?
Yeah, with the one giant model that took in every sensor as an input, it could only give one output, and that was one anomaly output, so you couldn't get an anomaly per sensor rather, and so it was a bit difficult to tell which sensor was actually acting up, because an incident on one lane might not slow the traffic in another in a significant way, and so you really need to detect that. So if Nupic had outputs on multiple outputs for anomaly scores, that'd be good. But yeah, it didn't really work because the score it produced was pretty much just very low the whole time, no matter what. And I'm not sure if that's due to that I didn't put enough data into the model, but that's just what I found. So I pretty quickly switched to one model per sensor. Thanks.
Yeah, it's an impressive application. And I had a question about the historical data, the incident data. How confident are you in the accuracy of that data to know if you should have gotten an anomaly score when you didn't or did?
I'd say fairly confident, because I think that the damage caused is a pretty good indicator of the severity of the incident, and so the length that it would take to clean up, etc. But I think it's fairly accurate because people are required by law to report any accident on the road to the police, and then I think they just have a data entry person entering it. But there's no real way to verify back because I don't have a time machine.
Right, I was curious that sometimes you're expecting to see an anomaly and you didn't, or it could have been because of data entry error on the of the incident report.
It occurred to me that, you know, just my casual observation as a driver, that sometimes accidents, they quickly go to the side and it doesn't slow down anybody, and sometimes it just backs up everything. So that the correlation between an accident and an anomaly in traffic flow is not always so great. And I didn't know if, and that sort of leads me to my question here was, are we using the traffic incident reports just as labeled data, or is that somehow the, I don't know, a goal of the system? Or what was the goal of the system? What would the ultimate utility be of the system?
I think the ultimate goal is to have it actually identify an accident that causes congestion. Because as you say, if there's a small rear end and they pull over, that doesn't really cause congestion. You really want the ones that do cause congestion because they're the more severe ones. But I think in my application, it was mostly just for now to search for anomalous traffic. And I think we found a fair bit of that. But yeah.
And you mentioned that there's a desire from city services to be able to identify actual incidents and therefore have greater confidence in when to roll trucks and things like that, right?
Yeah. So yeah, that's another public safety thing. So you can clear up accidents faster.
Would you imagine this is a real-time system if it were actually to be implemented?
Yeah, for sure. It's pretty simple just to hook up the data and have it run continuously, but that's something I need to organise with the council and the city.
Right.
I noticed you were using a threshold of 0.99 for anomaly. It seems very high. Does that mean you were getting a lot of false positives that you had to filter out by being very picky about what it calls an anomaly?
The 0.99, well, or 0.999 was provided to me by Matt Taylor, I think. And I think that was a standard threshold that's used in NUPIC projects, because you can take the logarithm of the anomaly likelihood, and then that will show you, because it really only peaks when it actually thinks there's anomalous behavior going on. So that's what I was told was best practice.
Okay. Thank you.
One question. So you trained the model with your supercomputer. Did you also run swarming to set the parameters for these models?
I did run a swarm, but it didn't produce results very different from that provided in the standard models. And I think there was a video made by Matt Taylor and Scott Purdy on whether or not you should swarm for anomaly detection. And I think the answer was basically no. So it was a waste of 3 hours for me.
So I'm just curious if maybe one of the reasons why sometimes it doesn't detect an anomaly is a min-max problem or something like that. If for this particular intersection, maybe is it like the number of incidents? Maybe there is this issue and that's why it doesn't detect the anomaly. You see what I mean? Or if the maximum in your model param is set at some value, but you end up with something that's much higher, gets kind of encoded
I think
in
the maximum number of vehicles through a sensor I was provided by the team here at Flinders was that 200 vehicles is pretty much the maximum number of vehicles you're going to get ever. Because that's like fully, because it's in 5-minute intervals, so that's pretty much constant, very high speed traffic over a single sensor.
Okay, interesting.
I was really impressed at, again, like Matt said, the whole end-to-end nature of everything you did. Plus, the other part of it was just the fact that you have so much data that you ran through and really got a sense. My question is, did you get a sense, what types of situations the anomaly detector worked well and what types it didn't? Do you have some sort of a meta-analysis of the overall behavior?
Frankly, I can't really tell which ones it's best at, because I think it found it didn't separate end of like 12 p.m. midnight very well from other times. and there was a huge gap in the data for about 3 days or something that it thought was very anomalous. But I'm not really quite sure about which bits it's best at. You just have to look through all the incidents that thought were highly anomalous.
Yeah, it's very challenging with all of this data to figure that out.
Yeah.
But that's, yeah, I think sort of piggybacking on Marian's thing, it might be interesting to do, offline, kind of a sweep through your parameters, and, there may be a way to kind of improve the overall system a little bit.
Yeah.
by parameters.
I am planning on running a search, basically, to see if it can find which parameters give the best anomaly scores for some incidents that I know specifically occur that did impact traffic, and then see if I can improve the anomaly scores that it gets for those.
And you mentioned you did a median filter before you fed it to the HTM?
It was a mean filter, rather. It was
Mean
wrong in the
filter.
video, but
Was there a reason for that? Did you find it worked better with that than without?
it didn't work any better or worse, I guess.
Okay. That's what I thought, yeah.
Any other questions or comments for Jonathan?
Thank you.
All right, thank you for joining us, guys.
No problem.